Hello my dear students, welcome back to the class. In today's class, we will learn still more problems and we'll finish off this chapter. Okay? Before going to solve this problem, one small note for you. There is no derivation for this. Just note a point. Capacitance of the spherical conductor is C is equal to 4 pi epsilon naught K into R, where K is a constant, dielectric constant. So if there is a dielectric medium, we have done a derivation for the parallel plate capacitance of the parallel plate capacitor. There is no derivation for the capacitance of spherical conductor. So the derivation is not there. Only you should know the expression, that is C is equal to 4 pi epsilon naught K R. This is the expression for the capacitance of the spherical conductor. If the medium is air, not the dielectric medium, then K is equal to 1. The formula becomes C is equal to 4 pi epsilon naught R. Okay. As you have PDF, today I am not going to write any questions on the board. I'll just solve it. Go through that PDF for the questions. Okay. First question. A charged oil drop remains stationary when situated between the horizontal parallel metal plates separated by 0.05 meter and potential difference of 2000 volt is applied between the plates. Find the charge on the drop if its mass is 1.5 into 10 to the power minus 14 kg. See here, oil drop remains stationary when situated between the horizontal parallel metal plate. So separation they have given D is equal to 0.05 meter. Potential difference they have given how much? 2000. Correct? Yes, 2000 volt. Then what is given? You have to find the charge on the drop of mass is given. What is the mass? 1.5 into 10 to the power minus 14 kg. So you have to find out the charge. How can we find out the charge? Can you help me? See here. Can I calculate the electric field from these two? Electric field is nothing but potential per distance, correct? So E is equal to V by D, or ED is equal to V. V is equal to ED. So E is equal to V by D. So I can write 2000 divided by 0.05. What is the answer you get here? Some answer you get. So then we know that F is equal to what? EQ. Now, can I write it as 2000 divided by 0.05 into Q is equal to F? We have to calculate the Q itself, but we don't know F. So, how can I solve it? We know that F is equal to ma. Correct? Here, acceleration is due to gravity, so I'll write it as mg. Now, we know mass. It is in terms of kg. So, can I write mg is equal to 2000 by 0.05 into q? This is also force, this is also force. So, I can write it like this. Correct? So, therefore, now when I substitute 1.5 into 10 to the power minus 14 into 10 is equal to into Q. Now solve it and give me the answer. What is the answer you get? We got the answer here as approximately 3.675 into 10 to the power minus 18 coulombs. I hope you got the same answer. 3.675 into 10 to the power minus 18 coulombs. Did you get the answer? Any doubts? Next. Next question. An electron is accelerated through a potential difference. An electron is accelerated through a potential difference of 45.5 volt. What is the velocity acquired by it? They did not give you any other values. You have to direct calculate only what is velocity acquired by it when it is accelerated through a potential difference of this much. This is electron they have given, so we know the mass of electron is 9.1 into 10 to the power minus 31 kg. Correct? The mass of the electron, we know it. We know the charge of electron also. What is the charge of electron? 1.6 into 10 to the power minus 19 coulombs. Correct? Okay, when the electron is accelerated through a potential difference of this one, what is the velocity acquired by it? How can we calculate? Can I say the kinetic energy gained or is nothing but work done? Work done in moving or the electron from or making it accelerated is nothing but work done. So when it moves, there is a kinetic energy. So I will write kinetic energy gained is equal to work done. So now if I substitute half mv square is equal to, what is the work done? Work done is nothing but potential into, what is the work done? Charge. Correct? Work done is nothing but potential into charge. Now it is electron. Okay. Half into 9.1 into 10 to the power minus 31 into v square is equal to 45.5 into 1.6 into 10 to the power minus 19. So v square is equal to correct? What is the answer? What is the answer you get? We get answer here. V is equal to 4 into 10 to the power 6. We get the answer. Try it. You will get the answer. Okay? Solve it by using the calculator. You will get the answer. For this one answer you will get, you have to take square root of that, then you will get this answer. Understood? Next, question number 3. "27 drops of water having the charge plus Q are joined to form a single big drop." Okay, 27 small drops are combined to form a big drop. Compare the capacitance of the bigger drop to that of the smaller drop. Capacitance of the bigger drop to the smaller drop. You have to compare the capacitance. Okay, here 27 small drops are added to form one single big drop. When we speak about the drops of water, it is nothing but spherical in shape. Correct? When it is spherical in shape, we say it the volume of the sphere, correct, of the 27 bigger drop volume of big drop is equal to volume of 27 small drop. Am I right? If all the 27 small drops are combined, only then big drop is formed. So therefore I can say volume of the big drop is equal to volume of the total 27 drops. Yes. What is the volume of the big drop? 4 by 3 pi r cube is equal to, what is the volume of the smaller drop? It is here. What is the volume of the smaller drop? 27. For one drop it is 4 by 3 pi r cube. For 27 drop, 27 into 4 by 3 pi r cube. Correct? Now, anything is getting cancelled. 4 by 3 pi will get cancelled. So what is the remaining? R cube by r cube is equal to 27 by 1. Or r by r is equal to cube root of 27 by 1. What is the cube root of 27? What is the cube root of 27? 3. So can I write r is equal to 3r? R is equal to 3r. Next, since it is spherical, we have not finished. We want to calculate capacitance. What is the spherical capacitance of the spherical capacitor? Four pi epsilon naught r by 4 pi epsilon naught r. Correct? See, this is nothing but we got it. I just gave you a formula to write a note from that. See? Now, can you help me? R by R. R is equal to 3R by R. So, capacitance of the bigger drop by capacitance of the smaller drop is equal to 3 by 1. So, it is 3:1 ratio. Correct? 3:1 ratio. Understood? Any doubts? What we have done? Volume of one big drop is equal to volume of the 27 small drops. So, combination of the 27 drop will give you one single big drop. So, using that concept, we have calculated the radius, then capacitance of the bigger drop by capacitance of the smaller drop. Next, question number 4. A spherical conductor having the potential of 6000 volt when surrounded by an oil of dielectric constant 1.5 and charged with 5 into 10 to the power minus 8 coulomb. Calculate the radius of the spherical conductor. Okay, spherical conductor will have potential how much? 6000 volt when surrounded by an oil of dielectric constant is given, charged with the charge is also given 10 to the power 8 coulomb. Calculate the radius of the spherical drop. We know the formula to calculate the spherical drop. What is the formula for the capacitance? Okay, here dielectric constant is there. Okay. But capacitance value they have not given you. So how can we calculate capacitance first? Q is equal to CV, correct? So I can write C is equal to Q by V. Q is how much? 5 into 10 to the power 8 divided by 6000. You'll get one answer. How much you get? We get it as 5 by 6. Ten to the power. See, this is not, I'm sorry, minus 8. Minus 11. Correct? Farad. We got capacitance. Now if I substitute here, will I get the answer? Yes. 5 by 6 into 10 to the power minus 11 is equal to 4 pi epsilon naught. K is how much? 1.5 into R. See here, I have not substituted for this one. How will I substitute is here? Very easy. R is equal to 5 by 6 into 10 to the power minus 11 divided by 4 pi epsilon naught into 1.5. This is nothing but now 1 by epsilon naught. 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power 9 into 5 by 6 into 10 to the power minus 11 divided by 1.5. Now you solve. You'll get the answer. Very easy. Here the answer is 5 into 10 to the power minus 2. Did you get the same? 5 into 10 to the power minus 2. What I have done here, you understood, no? Actually 1 by 4 pi epsilon naught is nothing but value is 9 into 10 to the power 9. You can use that also, or else you can if you have calculator, right? So we can multiply also 4 into 3.14 into 8.852 into 10 to the power minus 12. One answer you will get. Multiply direct. Then you can calculate also, or else you can calculate like this. Understood? Is it difficult? I don't think it is difficult, right? Okay, next. Question number 5. A parallel plate capacitor connected to a 2-volt battery no need to write question now. A parallel plate capacitor connected to 2-volt battery, okay, collects a charge of 20 microcoulomb with air as a dielectric and 40 microcoulomb charge with material as a dielectric. Find the dielectric constant of the material and the energy stored in the capacitor with the material as the dielectric. How can we calculate? See here, a parallel plate capacitor connected to 2-volt battery. Okay, first what we have to do is charge. In air they have given, another one, second time it is with the dielectric constant. Okay, with the air as a dielectric, the charge stored is correct. Q is equal to CV. In the place of C, capacitance is nothing but epsilon naught A by D. Correct? If it is a dielectric, then am I right? Am I right? Sorry. Correct? Now can you calculate? Try. Now can you calculate? Try it. Try. Can you calculate? We are not changing the distance. Then, whether anything is changed? V is changed? No changes in V also. So how can we calculate now? What is remaining? QA by QD is equal to 1 by K. You have to calculate K itself. But value of QA is 20 micro. $60 micro. K is equal to 3. Dielectric constant is 3. Correct? Now you have to calculate the energy stored in the capacitor. Half Q E square. What they have asked? Find the energy stored in the capacitor with the material as the dielectric medium. So material means QD we have to calculate. Correct? Half 60 into 10 to the power minus 6 into how much V? What is the V given? 2. So what is the answer? Square it is. So 1, 2 will remain. Correct? 2, 6 are 12. Correct? V square is not there. I'm sorry. You are right. Thank you for your help. Half QD. 2 will cancel. So 60 into 10 to the power minus 6 joules. Correct? Joules. Next. Understood? Yes. Question number 6. A parallel plate air capacitor consists of two plates, each of area 0.01 square meter, separated by a distance of 0.1 millimeter. It is charged to a potential of 50 volt. Calculate its capacitance, charge on it, and energy stored. 3 you have to calculate, correct? Parallel plate air capacitor consists of two plates, each of area 0. Okay, area is given 0.01 square meter. Then distance, separation is given 0.1 millimeter. Next, what is given? Charged to a potential V is equal to 50 volt. What you have to calculate? Capacitance. Correct? Can you calculate? Area is there, D is there, you know epsilon naught also. Calculate. Take your calculator and give me the answer. Give me the answer. Are you getting 885.4 picofarad? 10 to the power minus 12 pico. Are you getting? Yes, next you have to calculate what? Charge on it. How can we calculate the charge? We know C, we know V. Which formula? Q is equal to CV. Capacitance is 885 pico. V is 50. So what is the charge? Calculate. What is the answer you are getting? See, the answer here is 0.0443. Are you getting the same? Are you getting the same? I hope you will get the same, correct? Next you have to calculate what? Energy. Calculate energy. Calculate the energy. Is it half CV or CV square? Half CV square, correct? In the previous problem, we have taken half CV only. It should be CV square. What is C? We'll do this. Then we'll go for that. 885.4 into 10 to the power minus 12. V. How much? 50. Square. What is the answer? See, the answer we get here is 1.11 into 10 to the power minus 6. Joules. Are you getting the same? Joules. Previous problem, energy we got it as 60 into 10 to the power minus 6. No, it should be how much? The previous problem, we'll go for the previous problem. We had got the answer for K. Then you have calculate what? U. Question number 5. U is equal to half CV we have written. Correct? But there was no C. We wrote as Q. So that formula is not CV. It should be Q. I'm sorry, half QE, half into 16 to 10 to the power minus 6. Everything is correct. Only the mistakes what we had done is, sorry, there it was 2 volt battery. This is for this problem. Everything was correct. Only the formula what we had written was C, I think. It should be Q. Okay? We wrote is Q itself. Okay, then fine. Okay, fine. Q itself means then fine. I remember now. We wrote Q itself. Now the formula is CV square. So this is correct. For Q it is QV. Now it is CV square. Okay, fine. Thank you. Next. Shall we go for the question number 7? Yes, question number 7.